All right, so we're going to start today, Unit 8, Day 1, and this is all about what we call sequences and series that the whole unit's about. It's only about 6 days long, so it's a shorter unit, but it's probably something you've never really, you maybe seen some patterns, like when it says describe the pattern, but when it comes to actually a sequence or a series, it's probably totally new to you. So first off, a sequence, what a sequence is, it's an ordered list of numbers. So there is an order to it. It's not just a bunch of random numbers. It's not just a set of numbers. It is in a certain order, and it's following a pattern. Now, when we say terms in a sequence, that's each individual number is a specific term. So each number in a sequence, and that's going to be a term. So yeah, so when we say terms, we're just talking about each number, and they each have a name too, like the first term, second term, third term. We call them A sub 1, A sub 2, A sub 3. Yeah, first off, just looking at this, so maybe if you get a chance, pause the video if you're watching a video and try these. Like, just look at what is the pattern, and quickly describe what the pattern is, and then find the next two terms. So give yourself a chance to do that. Okay, so again, pause it and actually do that. But I'm going to continue on here. So hopefully you've hit play now because you actually paused it and tried it. So on this one, we're just adding 2 every time. So we're adding 2. So the next numbers will be 9 and 11. Okay, this guy here, if you look at those numbers, we're just dividing by 2. So divide by 2. So the next numbers would be 8 and 4. These numbers here, it looks like we're adding 3. So add 3, so it'll be 14 and 17. This one here, you're adding 7. So add 7 every time. Next number would be 55. 55 plus 7 is 62. Here, they're getting smaller. They're dividing. So divide by 3. So the next would be 3 and 1. Now it's alternating signs. How do we do that? How do you alternate signs? Well, that typically has to do with a multiplication. So in this case, we're multiplying by -2. So the next numbers would be 32, -32, and then positive 64. Okay. Now, and what we're going to really focus on in this unit is, well, I guess for tomorrow even, we're going to really focus on the ones where you add. Okay, so these right here, the ones that I circled, those are special ones. And those we call those, and again, we're kind of getting ahead of ourselves for a moment, and that's okay. I think it's okay to do. Those are called arithmetic. And you're looking at me thinking, you just spelled arithmetic. And that is true, I did spell arithmetic, but when it comes to naming it as a sequence, it's an arithmetic sequence based off arithmetic, which is adding or subtracting. So and when we say subtracting, I could say, no, actually a subtraction is just adding negatives. So you say add -2, that's adding. So arithmetic is adding. But we'll focus on day 2 is just strictly arithmetic. For day 1, we're looking at all kinds of patterns. Our learning target, I don't think I said it, but I can identify patterns and write sequences. So just any kind that there is. So this one, suppose you dropped a tennis ball from a height of 100 centimeters and the ball bounces back 80% of its previous height. So what is the first term of the sequence? Well, the first drop was 100. Okay, so that's our first bounce. What would the second term be? Well, the second term is how high did it bounce the second time? What was the second height? So for the second one, and how you'd find it, well, the second one's going to be 80, and you found it by taking 100 times 0.8. Okay, now how high would the ball go on its 5th bounce? Now this might kind of seem familiar with what we just got done with. We just did exponentials and logarithms last unit. So when it says, sorry, how high would be the 5th bounce? Well, sorry, I'm going to pause the video and get a drink here. Okay, I'm back. So if I want to find the first bounce, I'd multiply by 0.8. If I want to find the second bounce, I'd take that answer, which is 80, times 0.8. If I want to find the third bounce, same thing, 4th bounce, and then the 5th bounce, the 5th bounce, I need to do it 5 times. So basically a shortcut is I would take it times 0.8 to the 5th power, and that would be 32.768. You don't necessarily have to go that far with your decimal, but so after what bounce will the rebound be less than 6 inches? Okay, now you can use this. You can put it in your calculator like we did. You can use logarithms if you want. You know, we could say, so 100, how many times do I need to multiply by 0.8 to get 6, or even less than 6? So divide this over, so it'd be 0.06 equals 0.8x. I'm going to use a logarithm, so in my calculator, I'll do log 0.06 divided by, and the base is 0.8, so it goes on bottom, log 0.8. Looks like on the 12.6 bounce, so that'd be the 13th bounce was when it was less. The 12th bounce is a little bit more, so this would be the 13th, so this would round up to the 13th bounce. Okay, so right there it's a sequence that we did, a sequence of numbers, but it was all based off of an exponential function. So kind of see there's some repeats here, you know. So hopefully some of these sequences we're going to do, you've already seen them. You have a lot of experience with them because they're just special kind of functions. Okay, now how to write the formula. Okay, so I want to write the formula. I don't want to just write the sequence. I want to actually write it. So on the front side, I had you just describe what to do. Like you added 2, you multiplied by 5, you divided by 2, whatever it was. Well, now we want to write a formula for it. So the recursive formula needs to have 2 things. There's 2 things you have to write down. The first one is the initial condition. So the initial value, initial condition. And then the second one is the formula. So it's a recursive formula, which if you've heard the word recursive just means something happening over and over and over and over and over. It just keeps happening. So a recursive formula that relates each term, and we'll call each term a sub n. So n being which number it is. So a sub 1 is the first one, a sub 2 is the second one, a sub 3 is the third one, a sub n is the nth one. Kind of describes them all. So that relates each term to the one before it, which the one before it then would be a sub n minus 1. So whatever number, if this was a sub 5, the 5th term, 5 minus 1 is 4, so a sub 4 would be the one before it. Okay, so just n minus 1 just means the one previous to the a sub n. So on this one, we want to look at what happens. So write a recursive formula, then find the next 2 terms. So what's going on here? I think we had this on the front side. We're adding 3 every time. Well, first off, so this would be a sub 1, and then 8 would be a sub 2. So my video froze. And then 11 would be a sub 3, 14 would be a sub 4. Okay, so now what I need to do is write the initial condition. So I say what a sub 1 is. So this is my a up here. A sub 1 is 5. So you got to tell the person where to start. And then you got to say any number you want to find, any a sub n, is going to be found by taking the previous number. The previous number is a sub n minus 1. And in this case, I need to add 3. Okay, so this is basically this whole spot that's describing a number, take the previous term. So if I want to find a sub 2, I would plug in, so if I put up here a sub 2, it would be a sub 1, because that'd be n minus 1, plus 3. A sub 1 is 5, so 5, a sub 2 would equal 5 plus 3, which is 8. I'm supposed to find the next one, so a sub 3 would equal, well, 3 minus 1 is 2 plus 3. A sub 2 is 8, so a sub 3 would equal 8 plus 3. Supposed to find the next ones. Never mind. Okay, so this is just a good example. Let's do 5. Let me pause. I want to use some white out here. So what I want to find, again, this doesn't really help me with the question because it says we're supposed to find the next one. I'm supposed to find a sub 5, and I'm supposed to find a sub 6. Well, a sub 5 is going to be a sub 4 plus 3. A sub 4 is 14, so 14 plus 3 is 17. To find a sub 6, I got to take a sub 5 plus 3. Well, a sub 5 was 17, so this would be 17 plus 3, which is 20. And I know you could have found that easier just by adding 3, but I'm showing you how the notation works, what this notation is. So this is the recursive formula. These are the next two. Okay. So here, what's going on here? Well, first off, the first term is a half, and then every number is going to be the previous number, and then what am I doing to it? Well, here it looks like I'm adding a half every time, so plus 1/2. So if I want to find the next number, well, 5 halves, I got to plug that in here to find the next number. So a sub 1, 2, 3, 4, 5. So a sub 6 is going to equal a sub 5 plus a half. So it'd be 6 halves, which is 3. A sub 7 would be a sub 6 plus a half. A sub 6 is 3, 3 plus a half. It'd be 3 halves. 3 and 1/2, which would be 7 halves. If we're going to write it as improper, but if you put 3 1/2, that'd be fine too. Okay, what's going on here? I'm not adding something. It looks like I'm multiplying by 3. So the first term is 4. Then any term you want to find is the previous term times 3. Okay, so a sub n minus 1 plus or times 3. So if I want to find, this is 1, 2, 3, 4. If I want to find a sub 5 equals a sub 4 times 3. A sub 4 was 108. So 108 times 3 would be 324. And then if I want to find a sub 6, take a sub 5 times 3. So 324 times 3 is 972. And that's going up pretty fast. Those are the next two. So generate a sequence. What if I give you the formula and I want you to find the first 4 terms? So to find the first 4 terms. So we're trying to find a sub 1, a sub 2, a sub 3, a sub 4. A sub 1 is given. A sub 2 is going to equal a sub 1 plus 6, which is 4 plus 6, which is 10. A sub 3 is going to be a sub 2 plus 6. A sub 2 is 10. 10 plus 6 is 16. A sub 4 would be a sub 3 plus 6. Well, 16 plus 6, and that'd be 22. So the next 4 terms are 4, 10, 16, 22. Over here, this says take the previous term and multiply by -2. So a sub 1 is -5. A sub 2 is going to be -2 times a sub 1. So that'd be -5 times -2 is 10. Maybe I'll save some space here. So a sub 3 is going to be the previous term times -2, so it'd be -20 times -2 is positive 40. So -5, 10, -20, 40. That's the recursive formula. The one downside of recursive formula, it's not that hard to use, but what if I asked for the 20th term in the sequence? If I want a sub 20, you have to find a sub 1, a sub 2, a sub 3, all the way through a sub 19 before you can find a sub 20. Again, I'm saying sub as in subscript. I don't know if that's clear or not. Sometimes my speech isn't the clearest, but so a sub. So recursive formula is easy to use, but you have to, recursive means you have to do it over and over and over to get where you want. And explicit formula means you can jump straight to whatever term you want. So this one, I'm going to write it in here. This might be a little confusing, but it's describing the nth term of the sequence by using that number n. So if I want the 5th term, I'm going to use the number 5 to somehow find it. If I want the 112th term, I'm going to use the number 112 to find that number, like multiply by 5 and add 2 or something like that. So writing an explicit formula for each for each sequence, and then find the next 2 terms. So this one is not so easy. We'll kind of, when we get to the 2 specific kinds, we're going to talk about 2 specific kinds of sequences, arithmetic and geometric, and there's a formula for finding the explicit. Today we're just kind of like, let's kind of guess here. So what this is the first term, that's the second, that's the third, that's the fourth. So I want to try to find these using those numbers. So how can I use the number 1 to find 2, the number 2 to find 4, the number 3 to find 6, the number 4 to find 8? Because the 4th term is 8, so how can I use the number 4 to find 8? Well, maybe you figured out by now that any term, any a sub n, is just double its number. So the fifth term is going to be 10. The sixth term is going to be 12 because you just double it. Okay, so the next numbers will be 10 and 12. And that's just a sub 5, a sub 6, so 5 times 2 is 10, 6 times 2 is 12. This means I can fast forward. So if I want the 100th term, it's 200. And I found it pretty quick. I didn't have to do a recursive formula over and over and over. Look at this guy. And I would highly recommend just pause the video and look at it. But what's the pattern here? Like, what am I doing every time? So how can I use the number 1 to get 1? How can I use the number 2 to get 4? The number 3 to get 9? The number 4 to get 16? So what do I do with those numbers to get them? Well, it looks like they're squared. So if I want the fifth term, I'd take 5 squared. It'd be 25. If I want the 10th term, it'd be 10 squared or 100. So any number is going to be that number squared. So the fifth term, 5 squared is 25. The sixth term would be 36. Okay, so I'm just squaring them as I go. This one's a little bit harder to find, but how can I use the number 1 to get 1, the number 2 to get 8, the number 3 to get 27, and the number 4 to get 1/64th? Well, they're all on the bottom. All these, so this is 2 cubed, 3 cubed, 4 cubed, but it's on bottom. So it looks like any n is going to be that number cubed, but it's 1 over that number cubed. So if I want to find the next one, number 5, plug 5 in there. 5 times 5 times 5 is 125. That'd be 1/25. 1 over 125. So 1/125th. I said that wrong. 1/125th. And then 6 to the third is 2/16. So it'd be 1 over 2/16 or 1/216. Okay. Now, this is easier. If I give you the formula and I want you to find the first 4, so if you want to find the first 4, a sub 1, a sub 2, a sub 3, a sub 4, you are just going to plug in. So this would be 4 times 1 minus 3, 4 times 2 minus 3, 4 times 3 minus 3, and then 4 times 4 minus 3. So the first one's going to be 1, 5, 9, and then 13. Okay, over here. I'm going to write them down here. Okay, so I plug them all in. I get -4, -1, 4, and 11 when I plug those in. So it's almost like you think of this as an explicit formula is like just a function. Y equals x squared minus 5. Y equals 4x minus 3. So it's like the function which we've been using since Algebra 1. You've been doing linear functions, and then Algebra 2 we introduced, I guess you did quadratics in Algebra 1, and then we went over again in Algebra 2, and then exponentials and logarithms. We did all of these different functions. It's kind of what this is. It's an explicit formula is like writing a function for it. So it's a lot easier to jump right to whatever one you want.